Let's get started. Hi, everyone. Happy holidays, Christmas, and coming New Year. My name is Endo, Community Manager at Nexa. Welcome to the last Nexa Spaces this year. Today, we are excited to host Bitcoin Unlimited and Nexa Chief Scientist, Peter Rizun, who will be sharing insights into building a microchip for cryptocurrency, a microchip that aims to revolutionize transaction validation by being faster, more efficient, and cheaper than existing software nodes. I have prepared a couple of questions, but first let's quickly review the Australian Crypto Conference. We are having a lot of content around it. So, hi Peter, thank you for joining us.
Hello, yes, and Merry belated Christmas to everyone.
Merry Christmas. Maybe let's start with Australia and Sydney itself. We are really interested to hear how it went. Did you have a chance to explore Sydney, or maybe have any favorite spots, experiences apart from the conference?
Yeah. Well, I'm from Vancouver in Canada, and it's the northern hemisphere, so it's very rainy and cold right now. And as everyone knows, Australia is in the southern hemisphere, so it was summer when I got there, so it was fantastic to finally feel that sunshine on my face. I'd never been to Australia, and I've learned that Sydney it's a beautiful city. I would really recommend people going there and spending some time there if they have a chance. So yeah, highlight for me. I got away one afternoon to do a nice walk around Sydney Harbor. I saw that famous theater there. I forget what it's called at the moment. And so there's a park in behind that famous theater that has beautiful big trees that must be 200 years old. So that was a highlight for me, just walking through the park behind the Sydney Opera House.
Yeah, it was awesome. I also visited Sydney Opera House. It's really the signature of Sydney. Talking about Australia Crypto Conference itself, how it was? What were your impressions of the conference overall?
Let's see. I would say that I had some positive impressions and some negative impressions. So I'll just be fully honest. So first, it was really great to see everyone from Nexa and Bitcoin Unlimited. Like I got to meet you, Endo, for the first time. That was awesome. And Sick Pig, Andrew Stone, Andrew Clifford. We've been working together for almost 10 years now. So it's always great when I have a chance to see those guys. So that part of the conference was fantastic. Bitcoin was skyrocketing at the time, so there was a lot of excitement in the air. So that was nice. But the actual conference itself, I thought, could have been done a lot better. So I guess my first complaint is the venue where we gave our talks. It was terrible. So the conference was all in one giant room. So the area where all the vendor booths were connected by open air to the halls where the talks were being given. There weren't even any curtains up. So when people were giving their talks, as a listener, it was very difficult to hear the talks. And when I delivered my talk, so much background noise that it made it very awkward to focus and deliver a talk. So that was a real disappointment for me. I ended up not actually really being able to listen to any of the talks just because I couldn't hear them. Um, yeah, so I don't know why they couldn't have just put up a big curtain to block the sound.
Yeah, we were also curious about that. We also wanted to make a videos earlier than the original one, initial one, but couldn't do that because of sound.
Hmm.
Also, it was a big pleasure and honor to meet all the Bitcoin Limited and Nexa team for the first time myself, so it was amazing. Maybe let's jump to our main topic. It
Sure.
was awesome presentation to be said, really impressive. Not sure if everyone here has already heard that and seen your actual presentation. There is a video pinned in the Nexa main channel on X. If not yet, it is a must watch after the spaces. We also released a couple of videos about BLITZ and explaining cryptocurrency specific integrated circuits from the conferences earlier this month. Maybe people at the conference already got familiar with that, but for everyone here, what is BLITZ?
Right. So BLITZ is a hardware accelerator card. So it's a piece of hardware that's designed to plug into your computer and offload work that's very intensive for your CPU to do. So this allows your CPU to focus on other tasks and hard things, for instance, like elliptic curve point multiplication can be done on the card where the circuits are designed to be very efficient. Let's see. So this card, Blitz. So Blitz is it's very small. We had it Blitz at the conference. We had it working. We had it on the table, and it was demonstrating its signature verifications to the people that would come by. So it's a small card. It's 22 millimeters by 60 millimeters in length. So it looks like a stick of gum, and it has the M.2 form factor. So it fits into an M.2 slot on your motherboard, and it talks to the CPU over the PCIe interface. So that's a very fast interface for your computer to talk to external hardware. So your computer can read and write data to that card to offload things like signature verification. So BLITZ currently is based around an FPGA, a field programmable gate array. So that's this magic microchip that can be refigured on the fly to to be turned into basically any electrical circuit. So right now we have a design for BLITZ that does elliptic curve point multiplication on the FPGA, but the card doesn't have to be FPGA. So in the future, we want to make that ASIC based. So we want to have a specific ASIC running on the BLITZ card, so it's even more efficient for offloading tasks from the computer, and it's also cheaper to produce.
Yeah, thanks a lot for your explanation. It is really very technical and it's difficult to understand a lot of it. I'll probably try to go with simple terms. So, what Blitz is used for? I mean, its utility by design.
Sure. So just going back to the previous question, yeah, it's very complicated and technical, but at the highest level, just think it accelerates work from the CPU. So it takes work that your CPU has a hard time doing, and it does it faster, easier, lower power, things like that. So it just offloads work from the CPU at the highest level, and I think that's pretty easy to understand. So your question was, what is BLITZ used for, like in terms of what's this utility by design? So right now, it is designed to do signature verification for cryptocurrency. Since its first application is Nexa, and Nexa uses Schnorr signatures by default. So the first thing we did was make it do Schnorr signature verification for Nexa. And inside it, to do a Schnorr signature verification, we have to have the elliptic curve math programmed inside. So it has a SECP256K1 elliptic curve point multiplier inside there for the people that technical people here that understand what that means.
Yeah, thanks for that. Can it be used for mining or only signature verifications?
It could be used for everything. So it can be used for mining, for signature verifications, for transaction validation, uh, and that can all be done just by tweaking the the circuit description that we load into the FPGA. So I said it could be used for all three, but really it's only useful for the second one, for signature verification. So so right now, like, you could mine with BLITZ, but the problem is it wouldn't be cost competitive compared to mining with a GPU or mining with the new the new Nexa ASIC miners. So BLITZ costs too much in terms of dollars per the hash rate you get to be competitive, although it does work, if that makes sense. But for signature verification, it works really well. It can do tons and tons of signature verifications on a small little card. And then for full transaction validation. So right now it's only checking the signatures. In order for it to do full transaction validation, it would have to implement the full scripting language for Nexa. And right now we haven't done that. Our first step was just to focus on signature verification. But our goal eventually is to migrate everything to hardware. So eventually, yes, BLITZ would be able to do the full transaction validation.
So yeah, as I understand, eventually Blitz going to be itself kind of ASIC, yeah.
Mm-hmm. Yeah. So
Uh,
so I think it's for the people that don't know. So an FPGA, it's like I said, it's a field programmable gate array, and it's very different from a microcontroller or a CPU processor. When you program a CPU, you write software, and that gets compiled down into the computer's native instruction set, and then your CPU carries out the instructions and make up your program data back and forth, or to do whatever computations you need. So an FPGA is very different. You don't write software for an FPGA. What you do is you describe the circuit you want to synthesize within the FPGA. So if you want to add two numbers, you don't use like an add opcode. You don't. What you do is you actually create a hardware circuit like that has AND gates, OR gates, and different things like that physically add like two numbers coming in. They're carried on wires. So it's very very different. But what's so cool about it is the first step to making an ASIC is design the electrical circuit that you want your ASIC to be. So you design your electrical circuit in a hardware description language like Verilog, and then you synthesize that circuit onto an FPGA, because an FPGA is like that turned into basically any electrical circuit you can describe, and then you can test it out at the FPGA level, And then once you get all the kinks worked out, now you have a description of a circuit you can migrate to ASIC. So you can basically throw that over the fence to an ASIC fabricator, and they can turn that circuit, they can etch that circuit onto a little silicon wafer, and now you have a custom chip that does exactly what the FPGA was doing. But instead of costing $100 for the FPGA, it costs $1 for the ASIC chip. And instead of taking 10 watts to run the chip, it now runs with only 1 watt of power. So that's why FPGAs are so exciting. They're like a pathway to get to ASIC.
Yeah, that's so cool. I'll be honest, didn't understand the majority of technical parts, so we'll go just straight to the simple next question. Will BLITZ will be able to use for other cryptocurrencies, or it's only related to Nexa and will work only on Nexa?
So I guess the answer is both. Right now, our focus is Nexa. So when we release BLITZ, it will work out of the box with Nexa. But we want BLITZ to also be a research and development tool. So if people are willing to put in the time, there's no reason they couldn't adapt the BLITZ hardware to work with another cryptocurrency. For instance, like Bitcoin Cash uses the same elliptic curve as we use, but they use a different signature scheme. We use Schnorr. They also use ECDSA. So BLITZ won't work for ECDSA out of the box, but someone could do the work to make it work for Bitcoin Cash. But we're not planning to do that ourselves. Our focus is only on Nexa.
Yeah, that makes a lot of sense. If we are going to deliver these innovations to the industry, maybe, and others will get interested and get that first mover advantage. So that's really nice. You've also mentioned ASICs. Are you going to produce them yourself? I mean, if Nexa is going to produce them.
Yeah. So we are working on an ASIC at the moment. So we're still at the early stages there, and I've already talked a bit about the migration path from FPGA to ASIC. So the first step in ASIC development, and probably one of the most expensive steps, is just getting your circuit worked out on an FPGA. So you basically proven your design at the FPGA level. So the next step is to actually turn that into an ASIC, and we're working on that at the moment. This is it's quite a long process, so I don't think the ASIC will be in our hands till at least some point in 2026. But we're working on that right now, and we've already got a fair amount of data on like the number of transistors inside the chip, how big this chip would be, some idea of how much power it's going to consume, an idea of how much dollars it's going to cost for a given performance level. So we already have some pretty exciting results from our work migrating the FPGA stuff to ASIC.
Yeah, I can imagine a lot of work behind the scenes being put into this. You mentioned NASICs available until 2026 or so. What about BLITZ? When BLITZ would be available, or it's the same thing and will be available only together?
No, it's a different thing. So BLITZ uses an FPGA, so there's no really long lead time ASIC development in the path to release BLITZ. So BLITZ it works today. So we can use BLITZ today, and it works fine. But we're not quite ready to release it for the public because hardware is hard. So software, you're kind of in control of your own destination. You do the work, you write the software, you compile it, you test it, and you ship it. But with hardware, there's a lot of more things that can go wrong. So right now, one of the problems we have is the FPGAs we want to release with, I can't actually get them. So I'm trying desperately to find someone who will sell them to me, and I think I've identified that. But so that's one problem. So we're working with really cutting edge FPGAs. We're using the Ethnix brand, their titanium line of FPGAs, and these FPGAs are amazing. Like the performance you get out of them for the amount they cost beats Xilinx, beats Intel. They're really quite amazing. But these are very new products. So the FPGA I wanted to release this with, it was supposed to be done back in like September, but then they kept pushing the date. So they're now starting to ship them, but they're still hard to get. So I'm waiting for. So that is definitely causing us some delays right now. But I think it will be reasonable to have something for sale in the summer, so the summer of 2025. And our goal would be to release something like an experimenter's kit or a developer's kit. So something we don't want to set the user's expectation too high. We don't if you're not interested in hardware, if you're not really like a techie, you shouldn't be buying BLITZ at this point in time. This will be like if you're if you actually want to get some experience using this cool high end hardware. So it'd be something where it's a developer's kit. It comes in a box. You plug it in. Then the Nexa software recognizes the card, and you can start offloading signatures, verification to the card, and you have some way to kind of monitor the performance. And then there'll also be a whole developer's kit around that if you're interested in doing your own designs for BLITZ. If you want to, try to find a way to write a slightly different circuit or make some improvement on the work that we've done. So I think maybe this summer we can have that done.
Thank you a lot for your answer. It is really very exciting. Blades with ASICs on our own. I think this is very huge news and very big alpha. Getting back to your actual presentation, in the presentation you mentioned that cryptocurrency mining has undergone massive hardware evolution from CPUs to GPUs to ASIC miners. How did this inspire your vision for hardware nodes?
Um, I yeah. Well, let's talk about just how amazing the progress in Bitcoin mining has been. So if you look at like Satoshi mining the first Bitcoins back in 2009, he was doing that with his CPU. So his CPU would have got really hot, and the hash rate of his CPU was really low. So it took a lot of energy for him to mine Bitcoins. And then people found ways to do that with GPU to mine faster with less energy, and then ASIC they can mine even faster, consuming less energy. And if you plot the how much joules of energy it takes to mine, to do like a million hashes, it's improved by a factor of 600,000 times. So the current ASIC miners can mine 600,000 times more efficiently than Satoshi could. So I mean that's really amazing. Like I'm not talking about how much the network hash rate has grown. The network hash rate has grown by like a trillion times or something. I'm talking about just like the raw ability to do SHA-256. We can do SHA-256 with 600,000 times less energy today than we could in 2009. And that blew my mind when I learned that. And I'm like, well, let's channel that same innovative spirit into solving the entire cryptocurrency problem. So what we want to do with Nexa, or what we are doing with Nexa, is we're trying to tie in signature validation with the mining hash rate. So we're trying to create a cryptocurrency where if in order for a miner to improve its hash rate, to develop like a cool new tech to do it faster, better, it automatically will make his transactions per second faster and better too. So right now we have amazing tech for SHA-256 hashing. That's improved by 600,000 times, like I said. But our ability to do like signature verification has hardly improved at all because no one made ASICs for this. So if they had made ASICs for this, it'd be a totally different world right now. The scaling potential would be unbelievable. So that's what we want to do with Nexa. We want to tie mining hash rate to signature verification so that the network throughput can piggyback on the improvements that are going to happen automatically for mining as people just chase profit.
Yeah, so in simple words, we are going just on board with improvements from mining to transactions validation, yes?
Yeah. I would say the same economic incentive that led to the huge improvement in mining. We're trying to leverage that for transaction validation.
Yeah, so you've mentioned that Satoshi's choice of hash function might have missed an opportunity to link mining efficiency to transaction validation throughput. Could you explain how Nexa processes this differently? We are going to choose different algorithm, yeah?
Yeah, so in order to hash in Bitcoin, you just have to do SHA-256. And SHA-256 is, it's a very simple operation. And if you can do SHA-256 faster, it doesn't mean you can process transactions faster. So we want to link those two things together. We want to link hash rate to transaction validation. So it's easiest to think about this from the hardware perspective. So when your node is validating a transaction, there's going to be certain circuits that are exercised in your node, especially if it's a hardware node, that will check a signature, perform a UTXO lookup, things like that. And so what we're doing is we've designed the mining algorithm to exercise those same pathways through the circuit. So the idea being that anyway, like some innovative person could think to, okay, I have an idea that's going to allow me to mine Nexa faster, and I'm going to be sick because I'm going to do this optimization. We're trying to make it so by doing that, they automatically also gain the ability to verify transactions faster, and we think we've done that. The biggest piece of that puzzle is just forcing the miners to do the elliptic curve math behind signature verification as part of the hash function. And I talk about that in my talk. And there's that article that I think you'd like to end that describes that in more detail.
Yes, yes. You explained in your talk everything so brilliantly, and even I understood all the technical details, and it's really awesome. I was really impressed,
Uh, uh,
and haven't seen these innovations in industry for many years. So
Thank you very much. Yeah, I spent a lot of time putting that talk together, and it's a well, I find it's much easier to explain technical topics with animations, with drawings, especially if I can animate those drawings. So that's what I did in my talk, and also in the article that is a transcript of my talk. So I recommend users to look at that, and it'll probably be easier to make sense of what we're doing than just listening to me talk without the diagrams in front of me.
yeah, it really helps a lot, and we have awesome video prepared by Sasha, and it is on our X main channel. So make sure to watch everyone who is listening, and if you're a bit technical, you will definitely get that. It's explained really well. Let's get back to our initial talk, and your role at Nexa is implementing Satoshi's vision in hardware rather than software. What are
Mm-hmm.
the key advantages of a hardware-focused approach?
The hardware approach is just uh, I mean, it's everything. Like you said at the beginning, it allows you to make a node that's more reliable, that's faster, that uses less energy, and that's cheaper. Um, and then
Yeah,
that's
so
basically it.
we're basically just walking around the software and implementing all the solutions straight into hardware. Yeah.
Yeah, and I mean, this is like people haven't done this for crypto yet, but this is totally the regular migration path for most technologies. The CPUs are never controlling displays anymore. They now go through a GPU because it would just be crazy to have your CPU drive your display. No, we create specialized hardware to do specialized tasks. So for graphics processing, that's a GPU. Um, like when you plug your Ethernet connection into your computer, it's not like your CPU is directly connected to the wires on the Ethernet. Like there's a whole hardware chip that's doing the Ethernet communication, because that can be done. It's a very low level protocol, and you don't want to bog your CPU down with that. So much of Bitcoin, Nexa, cryptocurrency is the same way. Like there's so many simple tasks that shouldn't be done on your CPU and software. They should be done in dedicated hardware. I mean, the most obvious one is the signature verification, but most of the node is really ideal in many ways for porting to hardware. So I mean, the future I imagine is a Bitcoin node will be like a small little device that maybe it's even incorporated in your bin. It just sits there, and it doesn't cost that much money to buy. It's super fast, so you keep up with global scale transaction throughput. And if you want to talk to your node, well, you open up your computer and it just connects to your node that's sitting, by your router or inside your router over your local network. But all the work is being done by that little tiny chip inside that node, and your computer is just interacting with it as a user interface.
Yeah, it really makes sense. It's like with all the technologies probably just made a step forward, and yeah, looking forward to even more innovations here. This hardware node prototype you presented is fascinating. And
Sure.
you mentioned an Nexa ASIC will be ready around 2026. We will have BLITZ maybe during the summer of 2025. What
Mm-hmm.
other milestones can the community expect in the meantime? We will have some little things before this shows up.
Uh, I'm not sure. Well, I guess it depends what you mean by little things. So we had our head down for the last year, working really hard on this FPGA stuff, and we've got a lot of results that we haven't shared yet. So over the next 6 months, I'd hope to release more articles and little video snippets and pieces of software, pieces of FPGA code. to kind of describe and allow the community to learn more about what we're doing and
Yeah,
how
thank you.
hardware
So
development.
we will see how it will develop in the future. Thank you so much, Peter, for sharing your insights into this innovative approach to the cryptocurrency scaling. Before we close, is there anything else you'd like to share with the community or add?
I know. I think we've covered things quite well. Yeah, thank you for having me on.
Thanks everyone here, and stay tuned for our next space where we will explore more about Nexa. Next time, Andrew Stone going to be with us. Don't forget to join our community channels, check out our website, and watch Peter's presentations pinned on our main X channel. Thanks for joining us, and see you all next time.
Hey, thank you.
Bye
Take
bye,
care.
guys.